If you've been listening to the other podcast, you know that we casually say that water is evaporating from the oceans, from the soil, from the lakes. Plants are photosynthesizing, so they open the stomatas on their leaves to capture carbon dioxide from the atmosphere. They bring up water from the root system using this nice capillary action, and when they open the stomata they are trying to be careful to not lose that water, not lose too much of that water while they are capturing the carbon dioxide from the atmosphere. They need carbon dioxide and water together to combine with sunlight to produce do photosynthesis and produce carbohydrates, sugars, whatever they need to live, to grow, to sustain, and so on. When you think, and we are talking about clouds and rain and snow and water moving around in these circulations, but if you think about it, if we can follow a particle of water, one molecule of water, somehow magically someday we'll have a little robot sitting in the water molecule and going around. You want to see where all it goes before maybe it comes back somewhere where it started or ends up somewhere else. These are called this is called water cycle. In general, we talk about cycles. We will next look at carbon cycle. We mentioned elemental cycle before. When we say elemental cycle, typically we are talking about carbon cycle, but there is also nitrogen cycle, phosphorus cycle, iron cycle, sulfur cycle, and so on and so forth. So water cycle is one good example. There are many details in terms of the science, the dynamics, the processes, and how human beings actually perturb the natural water cycle and so on, that you can follow up on your own. Let's start with some simple facts again. I'm taking these figures from sites of NASA and other agencies that provide free figures. Where is Earth's water? 96.5% or so is in the oceans. But remember, ocean water is salty and we cannot drink it directly. And yet we have lots of freshwater problems on Earth, so you know that we are not managing water so well. About 1.7% is in the lakes, rivers, streams, and soils. So if 96.5% is not directly drinkable, then of all the water that's on the planet, only about 3.5%, 3% for simplicity, only about 3% is fresh water, but out of that 1.7% or so is in the polar ice caps, glaciers, and permanent snow that doesn't melt from year to year. Of course, global warming is changing this. That means only about 0.001% is in water vapor in Earth's atmosphere, even though it's so important in terms of energy, because remember, when it condenses it releases all that heat that is picked up from the ocean, soil, and lakes as latent heat, and it's released in the atmosphere, which drives cyclones and hurricanes, typhoons, rainfall, thunderstorms, transport of energy from the low latitudes to high latitudes that we talked about, and so on and so forth. Obviously, this gives you a sense of how careful we have to be on how we use the fresh water, that's precious little fresh water that's available. Of course, now people are dreaming more and more about desalination or desalination of ocean water to produce fresh water. Of course, if you do it in a very large scale, what do you have to worry about? Obviously, you will have to worry about where to put all that salt. All the fish, this nice dolphin is being shown here. They have evolved in the salty water. Some have evolved in lakes and rivers. They are used to the salt in the water they are living in, because they have to decide how much water to drink, how much water to get rid of from the body, because the cells need to maintain their level of salt. Our sweat is a little salty, for example, right? So our body also has salt, but it also has to regulate salt. If you go in the ocean and stay too long, you will see the impact on your skin. It gets wrinkled because the body is beginning to exchange water with the salt, the process of osmosis that you have heard of, and so on. So we have to be careful about using the fresh water that's available and not dream that we can solve all the problems by just desalination, but someday maybe that will be possible. It's very humid, so I'm talking loudly and I'm feeling thirsty, and I forgot to bring my water bottle here. So let me manage this podcast. Earth's water cycle then in a simplistic way. There are places where water is stored, of course, oceans, lakes, rivers. Rivers are flowing, lakes are sitting there, ocean is often just sitting there, and there is also water called groundwater, which is under the ground. We can't see it at the surface unless it comes up as river or lake, and soil moisture. So soil is not always dry. If you go to the desert, of course it's very dry, but if you go around agriculture, in a forest, or in places that you walk around when you go to school, if you're walking or riding your bicycle, you can look around. The soil also has some level of soil moisture depending on where it is. How does the water flow around? So you can think of these as tanks of water. Let's say in your house there is a tank at the top. In India it's very common to have a big tank of water at the top of the building or at the top of the house, and you use that for various purposes. And then there are flows that go from one tank to another, and these are often called fluxes, which I didn't define before. We talked about radiation in watts per meter squared. This is a flux. So when you open a tap, water is coming into the bucket, so water is coming at some rate of flow. Let's say it's 1 liter per minute or so, depending on how fast it is. Okay, so that's a flux amount per time, sometimes per area, like watts per meter squared of energy coming from the sun, or watts per meter squared of thermal energy going out from the earth. And there is a reservoir, there is a tank, so in the bucket you have so many liters of water. Similarly, groundwater and all the storages of water have some amount of water in them, and the flows are the fluxes. So you have things like surface runoff, water flowing on the top, and you have evaporation, which is going from the water in the soil or ocean or lake or river into the atmosphere, and there is precipitation, which is falling back to the earth as rain or snow. So rain is just water. When we say precipitation, it can be hail, it can be snow, it can be rain. Okay, so it's a broader term when we say precipitation. So a lot of water is also locked up in ice sheets, as we saw here. About 1.7% is in polar caps, glaciers, and permanent snow. I'm aware that I haven't defined glacier yet, but okay, let me just say it. When snow falls on land, it may be so cold that it doesn't melt by the end of the year. So winter comes, it snows because it's cold, either on the mountain top or at high latitudes, and then spring comes, summer comes, and next fall comes and winter comes. If the snow that has fallen this winter does not melt till the next winter because it's cold, and more snow falls on top, and when snow keeps falling, it gets heavier, it gets compressed, and it becomes a glacier. We'll talk about this more when we come to the Earth system again, but just for now, remember simply this way. So ice sheets are when the glaciers become very large in area. Okay, so there is water storage in the oceans, and the sea level decides how much water is stored, and of course how much volume is occupied by the water depends on how warm it is or how cold it is. Cold water has high density, and remember, density is mass divided by volume. So if you take the same mass and freeze it, or cool it, then the density increases, which means mass is the same, so volume has to decrease. If you heat it, then the volume increases. So sea level depends on how warm or how cold the ocean is, or it can also depend on the melting of the ice sheets, which releases water into the ocean, or melting of the mountain snow and so on, that can come as rivers into the ocean. Okay, so this is in a simple way the water cycle. Of course, water goes into the ground and gets stored as groundwater. It comes back out into lakes and rivers and so on. And of course, human beings are putting bore wells and other things and extracting all that water for drinking, for irrigation and so on. And there are details. How long does it take for the groundwater to get stored? From the surface, water has to go down in some way. Obviously it takes a long time, but you can extract it very fast. You can put a bore well and take out a lot of water, but that water does not get recharged. New water doesn't come to replace the water you are taking out very fast. So we are exhausting, or we are consuming, or you are spending the groundwater very fast in most places. Okay, so let me leave this here, and I have a couple of more figures that will look at where the water falls as rain or precipitation, and where the evaporation happens, and they are related to the winds we have looked at before. So we'll come back and look at that in the next podcast. Okay, see you then.